Hello viewers, in today's class we are going to discuss one important and conceptual problem from definite integrals, right? And here we have to evaluate this definite integral from -1 to 1, and the function is e raised to x signum of x plus 2 divided by greatest integer of x minus 1, right? So here we see that our integrand, it consists of signum function as well as the greatest integer function, right? So let us start. Now let us first take this integral as I, right? Now here what we will do, we'll try to apply the definitions of signum function and greatest integer function to this entire function and to simplify it, right? So let us first take the definition of signum function, right? So signum function is defined as signum of, say, x is defined as plus 1 when x is greater than 0, and signum of x is equal to 0 whenever x is equal to 0, and signum of x is equal to -1 whenever x is less than 0, right? So this is a very important definition to evaluate integrals of this type, right? So here we have signum of x plus 2, right? So what we will do, we'll replace this x by x plus 2, and let us see what happens. So here we have now signum of x plus 2 because we are replacing x by x plus 2. So now signum of x plus 2 is equal to plus 1 whenever x plus 2 is greater than 0, and signum of x plus 2 is equal to 0 whenever x plus 2 is equal to 0, and signum of x plus 2 will take -1 value whenever x plus 2 is less than 0, right? So now here we see that we have two inequalities and one equation. So if we further write it, we can write it as x greater than -2, and here we have x is equal to -2, and here we have x less than -2, right? So this is how we define the signum of x plus 2, right? And we'll in our next steps we'll take the value of, or we will simplify this greatest integer of x minus 1 using the limits, right? So now let us take the real number line and see. Here we have the real number line. This is -infinity, this is +infinity, and here what we will do, we'll plot the three numbers. Two numbers come from the limits, that is -1 and 1, right? And x is equal to -2, it comes from the signum function, right? So -2, it lies somewhere here, right? So here in the number line we have displayed three numbers. The first one is the lower limit, that is the -1. Second one is the upper limit, and the third number is x is equal to -2, which comes from solving x plus 2 is equal to 0, right? Now here we see that we have the greatest integer of x minus 1, right? And whenever we have the greatest integer function, we deal with integers, right? So here we see that between -1 and 1 we have 0 as the integer, right? So we'll also represent 0 between -1 and 1, right? And in our later steps we'll see that this 0 is the breaking point. Breaking point means the integral can be written as a sum of two integrals I1 and I2, right? So at x is equal to 0 we'll break this integral I. So now here we see that we have this number -2. So let us encircle this -2, right? So now here we encircle this -2, and from this definition we see that we have two inequalities. The first one is x greater than -2, right? So x greater than -2 is this interval, right? So this is an important point here, x greater than minus 2, right? So it implies that we have the interval minus 2 to infinity, right? And the second one is x less than minus 2, right? And x less than minus 2 is this interval, right? And here will not include this point minus 2. So x less than minus 2 is the interval minus infinity to minus 2, right? So now here we are discussing these two inequalities because see, we have the limits minus 1 and 1, right? From minus 1 to 1 we have to integrate this function from minus 1 to 1, and 0 is the integer which lies between minus 1 and 1, right? So here we have the greatest integer x minus 1. So what we will do, we'll first take the integral from minus 1 to 0, right? So I can be written as I1 plus I2, and I1 is from minus 1 to 0. We have e raised to x signum of x plus 2, and then here we have greatest integer of x minus 1, right? And I2 is from 0 to 1, right? 0 to 1, and we have e raised to x signum of x plus 2 divided by greatest integer of x minus 1, right? Okay, so now we have these two integrals. Now here what we will do, we'll try to assign a value to this signum of x plus 2 and this signum of x plus 2, right? So now if we look at these this real number line, we see that we are integrating from minus 1 to 0, right? Minus 1 to 0, and this interval minus 1 to 0, it lies in the interval minus 2 to infinity, right? And minus 2 to infinity implies that x is greater than minus 2, right? So all the values of x which lies in the interval minus 2 to infinity are greater than minus 2, and all the values of x which lies in this interval, that is from minus infinity to 2, they are all less than minus 2, right? So when we integrate from minus 1 to 0, from minus 1 to 0, it means all the values of x are greater than minus 2, right? So when x is greater than minus 2, we see that signum of x plus 2 should be equal to plus 1, right? So this signum of x plus 2 will take the value plus 1, because minus 1 to 0 we are taking this interval, right? And similarly when we integrate from 0 to 1, from 0 to 1, and again we see that this interval falls in this interval, that is from minus 2 to infinity. So again signum of x plus 2 is having the value plus 1, right? So what we have done here, we have written signum of x plus 2 is equal to plus 1 at this or in this integral, right? And here signum of x plus 2 also takes the value plus 1, because both the intervals, that is minus 1 to 0 and 0 to 1, both these intervals are subsets of the interval minus 2 to infinity, and all the values which lies between minus 2 to infinity are greater than minus 2, and when x is greater than minus 2, signum of x plus 2 takes the value plus 1, right? So now we have decided the value of signum of x plus 2 in these two integrals, and now let us decide the value of greatest integer of x minus 1, right? So let us first take the I1 integral, right? So we have x greater than or equal to minus 1 and 0, right? In the first integral, x lies between minus 1 and 0, but we have to find the value of greatest integer of x minus 1, right? So what we will do, we'll subtract 1 throughout this inequality. So what we will get, minus 1, here we'll have x minus 1, here we have 0 minus 1, so this is minus 2, and this is x minus 1, and this is minus 1, right? So we got this inequality. So by definition of greatest integer function, the value of greatest integer of x minus 1 is minus 2, right? And similarly, in this integral we have x lying between 0 and 1, right? But we need to find out the value of greatest integer of x minus 1. So again, we'll subtract 1 throughout, so we'll have 0 minus 1, and here we have x minus 1, here we have 1 minus 1, so we have minus 1, here we have x minus 1, here we have 0. So by definition of greatest integer function, the value of greatest integer of x minus 1 is minus 1, right? Okay, so here we have this value is equal to minus 2, and this value is equal to minus 1, right? So now we can rewrite these two integrals as minus 1 to 0, and we have e raised to x, here we have plus 1, and divided by minus 2, right? And here we have dx, and in the second integral we have 0 to 1, e raised to we have x, here we have minus here we'll have plus 1, signum of x plus 2 is plus 1, and divided by minus 1, right? So now we have these two integrals. Now let us simplify these two integrals. So what we will get here, we have minus 1 to 0 and e raised to minus x over 2 dx plus 0 to 1, and here we have e raised to minus x, right? Okay, so now the integral of e raised to minus x by 2 is minus 2 e raised to minus x over 2, and limits are from minus 1 to 0, and here the integral of e raised to minus x is minus e raised to minus x and 0 to 1, right? So now here we'll take minus 2 outside, so we have minus 2 e raised to minus x over 2, limits are from minus 1 to 0, and here also we'll take negative sign outside this bracket, and we have e raised to minus x, and limits are from 0 to 1. Now substituting the limits, what we will get, we have minus 2 and e raised to here we have x is equal to 0, so this term is 0, minus e raised to, here we have x is equal to minus 1, so minus and minus becomes plus, so we have plus half here, right? And here we have e raised to minus 1 because x is 1, and here we have x is 0, so we have e raised to 0, right? So now we can simplify it. Minus 2 e raised to 0 is 1, here we have square root of e, because e raised to half can be written as square root of e, this is minus, this is 1 over e, and this is 1, because e raised to 0 is equal to 1. So now simplifying it further, we can write minus 2 plus 2 times square root of e, and then we have minus 1 over e and plus 1, right? So I can be written as 2 times square root of e minus 1 over e, and minus 2 plus 1 is minus 1, right? So the value of this integral is equal to 2 times square root of e minus 1 over e minus 1, right? Now this expression can also be written as 2 times e raised to half minus, we can write it as e raised to minus 1, and this one can be written as e raised to 0, right? So this is how we solve this important and conceptual integral.